All right, today we've got a fantastic story of scientific detective work for you. It's a tale of how a shadow cast by a spacecraft, helped us solve a huge cosmic puzzle happening right in our own backyard. I know, it sounds like a riddle, right? How on earth can a shadow, something that's literally the absence of light, reveal a deep secret of the cosmos? Well, stick around because that's exactly what we're going to unpack. And the answer is way more clever than you might think. Okay, so let's set the scene. Our whole story starts with something you can't see, you can't feel, but it's constantly surrounding our planet. It's this invisible wind flowing from Earth out into space, and it's made of something called cold plasma. So what is this cold plasma? Well, think of it as a super thin, low-energy soup of charged particles, ions and electrons, that are always escaping from the very top of our atmosphere, a place called the ionosphere. Now, don't let the name fool you. It's not cold like an ice cube. It's just cold in plasma physics terms. But what's really important is that this stuff completely dominates the magnetic environment around our planet. It's a huge player in the game. But here's the thing. For the longest time, this invisible wind was a total enigma. Scientists knew it was there, but it was hiding a really fundamental secret, one that our best instruments just couldn't seem to figure out. And that big secret was its temperature. I mean, think about it. We had this massive wind blowing off our planet, but we couldn't take its temperature. And without that one piece of data, we had no idea how it was getting heated up, how it was being energized as it journeyed millions of kilometers out into space. It was a giant blank spot on our map. And this slide just nails the problem. See, measuring hot plasma is pretty easy. The particles have so much energy they just slam right into our detectors, no problem. But cold plasma, it's a whole different story. A spacecraft flying in sunlight naturally builds up a positive electric charge. And these cold plasma particles, they're also positively charged. And you know the rule, like charges repel. The particles were literally being pushed away from the spacecraft, making them totally invisible to the very instruments trying to find them. So how do you measure something that's actively dodging you? Well, instead of trying to build a better net, scientists got really, really clever. They realized the answer wasn't in catching the plasma itself, but in looking at the disturbance, the mess the spacecraft was making as it flew through the plasma. You know exactly what I'm talking about. Picture a boat speeding through the water. It leaves that V-shaped wake behind it, right? A spacecraft plowing through this plasma wind does the exact same thing. It creates what's called a plasma wake, a kind of shadow, a region of disturbance in the flow right behind it. Now, for years, this wake was just seen as noise, annoying interference that was messing up other measurements. But then a team had this absolute light bulb moment. What if the interference was the signal? They realized that the shape and size of this wake, specifically how deep it was directly tied to the properties of the invisible plasma flowing all around it. And it all boiled down to two key things. First, the speed of the plasma wind. If the wind was faster, the wake looked different. Simple enough. But second, and this is the crucial part, the depth of the wake also depended on the ratio between the temperature of the electrons and the ions in that wind. Suddenly, they had found their secret decoder ring. So, armed with this brilliant new trick, scientists could go back in time. They could dig through years and years of archived data from old missions. But now, they weren't looking for the plasma anymore. They were looking for its shadow. And what they found was incredible. And we are not talking about a small data set here. This wasn't just a few observations. Scientists combed through nearly 30,000 different measurements, all from the European Space Agency's cluster mission, gathered over an entire decade. This was a massive, deep dive investigation. And here's the most ingenious part of the whole detective story. Remember how the wake depended on both speed and temperature? Well, the scientists filtered their data, looking only for the times when the plasma speed was constant. By doing that, any change they saw in the wake's depth had to be because of a change in temperature. They perfectly isolated their variable. It was just brilliant. So what did they find? All right, here's the first big reveal. As this plasma wind flows away from Earth, the ions, those are the heavier, positively charged particles, they heat up way, way faster than the tiny little electrons. This was a huge clue that some process out there was specifically targeting and energizing the big guys. But then, things get weird. Once the plasma gets about 16 Earth radii out, we're talking over 100,000 kilometers away, the whole situation flips on its head. All of a sudden, the electrons start getting superheated, their temperature rising way faster than the ions. It's like they crossed some invisible line in space, and a completely different heating mechanism just kicked in. And you don't have to take my word for it. This quote from the actual research paper lays it out perfectly. The scientists themselves state that this pattern is clear evidence that electrons and ions are being heated by totally different processes as they fly down Earth's magnetic tail. The case was finally cracked wide open. So, you see what happened? By solving the first mystery, the temperature, they immediately stumbled upon a brand new one. What in the cosmos is heating these particles in two completely different ways in two totally different places? A whole new cosmic whodunit had just started. Okay, let's look at the lineup of prime suspects. For the first crime, heating up the ions closer to home, the main suspect is a type of magnetic wave called an alphin wave. You can think of it like pushing someone on a swing at just the right time. These waves have the perfect rhythm to pump energy directly into the ions. Now, farther out, the culprit for heating the electrons is probably something called a dipolarization front. These are like powerful, sharp shock waves in the magnetic field that squeeze and accelerate the tiny electrons as they pass through. And here's the most exciting part. This discovery doesn't end the story, not at all. By using a spacecraft's shadow to finally take the plasma's temperature, scientists have uncovered this much deeper, way more complex heating system at play around our planet. The investigation is really just getting started.
And it just leaves you with this amazing thought, doesn't it? It's a powerful reminder that sometimes the biggest discoveries aren't made by looking directly at something new, but by finding a clever new way to look at the subtle clues that are left behind. It makes you wonder, what other incredible secrets are hiding out there, just waiting for us to figure out how to look in the shadows?